So today we have a great opportunity to listen from an expert in optics about adaptive optics. It would be my dear friend Abhailash. He has done his PhD from IIT Madras and has gone to a unique combination of fundamental and applied physics during his postdoc, and he has been continuing in that field. And today he'll be presenting his fundamental part of his research along with how it comes out to its application. So may I take this opportunity to welcome Abhailash.
Okay, thank you for the introduction. Hi everyone. I'll be talking about adaptive optics from astronomy to medical imaging. So it's a range of fields where adaptive optics is being used. So I'll give some important aspect of why adaptive optics is important in astronomy and medical imaging first, with like a few slides, and I will say what are the developments recently have been there in this particular field. Adaptive optics is named in wavefront shaping later on, and the story how it has gone all the way until now, and what are the current challenges. And then I will go deep into some advanced research or which I have done like last 2 years in University of Utrecht and in Twente, and where I focus on a particular problem with a proof of principle experiment, how people are actually starting with some concept. It's always a proof of concept or hypothesis people start with, which will be carried by other researchers in different fields to implement more into reality. So I just wanted to say in astronomy, and in the old age people were trying to look at the stars far away, and at night we see the stars, and this starry night is the one of the beautiful thing I also see. In some days we don't see any clouds, and the clear sky and the stars are quite really nice to look at. You all have experienced that. But in all days, this telescope is being developed to see these celestial objects in the space and in the universe. And now, I think in 2016, people could see or locate a far away star which is away from our Milky Way, and which is located and identified by Hubble telescope. So the basic principle of a telescope is we have two lenses to image an object far away from our Earth, and for example a star far away, and we can use one lens to image it or two lens system to image it. And so or we can use a spherical mirror which has a particular radius of curvature to image it. Doesn't need to be lens. We can either use mirror or lens, which will really do what we want. So basically, the first task is, why do we need adaptive optics? And before that, what is optics? Sukanya can just mention what is optics, because you have heard about it, right?
Yeah.
What do you know about optics?
Optics is generally optical things. Firstly, when we heard of this term, we think of our eyes.
Yeah.
So optics is the branch of science dealing with this seeing of things.
Okay, so what came to your mind is seeing of things, right? So in order to see this, what do we need? We need
telescope. Means many instruments.
You have eyes to see, right? And if I switch off this light here, will you be able to see me?
No.
No. So what do
First
you need?
light is needed.
Light is needed. So the branch of physics where we deal with light is mainly optics. That's the simplest way to answer it from my point of view. And if somebody has other definition also can be, you can shoot some definition you want, obviously. But in a telescope, what is the basic idea is this system is the telescope, and what we are intended to see is some star far away, and we can use a camera. This yellow box is a camera, or anything which can capture the image. So this is just a simple naive model. However, in the Earth, you can see the surface of the Earth has like many layers. You have all studied, right? And the air is moving around, and therefore the refractive index fluctuation is there. Basically, the other molecules and all. So there is the dusty regions around Earth, and after that, this is space. Space, the light travels without having any problem, right? And the refractive index is of the space 1. And then what happens is if you consider this telescope is set up in Earth somewhere around in your house, and you can look at it and locate it there. So basically it is in Earth, but this light from the star has to travel all the way from space through the layers of the Earth, this inhomogeneity of refractive index, and then it has to pick up by the telescope, right? But there is something going on in between before entering Earth. So it gets going, it goes through this refractive index variation, atmospheric, I just call it in simple words, fluctuations, whatever. So light gets distorted, then what will be observed is something like this. Light gets distorted and we don't get a star here. Rather what we get is kind of blurry image. Okay? And in the old days, why? Why? Because the light is going this way, and because of the refractive index variation.
No. When we look at your eyes, we can see it perfectly, right? But when you use a camera, it's blurred.
No. Even if.
Is it really the case?
When we see it, we like.
For example, sun is shining. You're okay, or you are looking at the moon. It is covered with a cloud at some times, right? Cloudy, and you don't see the full moon.
Actually, the star is blinking just due to
Exactly.
right?
Exactly.
Yeah.
What?
Star is blinking.
Why is it
But
blinking?
moon is not blinking.
Okay. Very near.
Moon. Come on, questions. Huh?
Starlight passes through the layers of atmosphere and got refracted. That's why we see it blinking. Right?
Yeah.
That's the same thing. Right?
Yeah.
Now the blinking. Okay. This is a good point. I think it's a why blinking? Why blinking? Because it's a time-dependent phenomenon. But why is it blinking?
Because the light passes through different layers. And
So what is the time-dependent factor there? Because it blinks. There is a constant light.
It's not there.
If there is not there, so time. If we temporally speaking, the signal is fluctuating.
Yeah.
Right? Then there must be some temporal factor there.
But he thinks that it is just blocking sometimes and not docking.
No.
Because of the refractive index.
Why did he talk about
The path of the light is getting
Like getting higher and lower
Yeah.
because of the fluctuation.
Yeah.
Yeah.
What is the same?
Yeah.
I didn't hear that.
So,
Why moon is not?
huh?
Why moon is not blinking?
It's very big and so near.
Is moon shining first of all?
The good question. Why
What
moon
was the
is
question?
shining? Why moon is shining? You asked, right?
The distance
Sun is,
between
no, other stars are blinking and moon is not blinking, right?
Yeah.
Starlight has
Why?
Wait, one at a time, otherwise it's very confusing.
What is the difference
Niveti has
between sun
something.
and moon?
Niveti has something to
It's a
say.
star and the light is coming from there, right?
Why stars are
the distance.
No, right.
Distance is very different.
One moment. So Niveti has something to say.
Yeah.
Moon does not have its own light, but star produces its own light.
Is that a,
Then sun does not blink.
Why stars are
like what are
Why stars are blinking? That's one of the biggest questions. Can somebody explain? I mean,
The
this room did not give the
amount of
answer.
light we are receiving is very low.
Huh?
and it has to travel a long distance.
Okay.
Comparing to a distant star, the sun and moon are very very near.
But
Okay.
that the extra distance is through space, right? Where nothing happens.
No. There are various other things that the starlight can be.
It refracts
We
in
we are only
different layers
discussing
of
about the
Okay, Nivedya has something, some point.
It refracts in different layers of atmosphere, the light from the...
But then why is it
Different
blinking?
days, different
Yeah,
seconds,
that's
different
why we are
minutes.
erecting telescopes in the space to get
Yeah,
rid of these
to avoid-
No, that's not the reason that the stars are blinking. That we are sending telescope into space.
Yeah,
We are sending
what is the
telescope
basic
into
difference
space.
to avoid these
between the two?
Sorry?
What is like ask what is the basic difference between the moon and the star?
No, you
That is not the question. Star is blinking is first question.
No, I'm saying in the image that you see, the what you see as the moon. I mean, I mainly want to say
see there.
size.
You're right.
The size of the moon.
You are right.
And the size of the stars. I mean, both, even the moonlight is also blinking, but the error gets because you're seeing a big
So
disk or
the
something.
good example is if you take features inside the moon, you will see that the features, go off clarity and come back to clarity.
So of course the light has to blink
Even if
because
you-
it's the refracted index.
Yeah.
But when it is a big object, the error just cancels out like infinity is a finite thing.
Yeah, the apparent size
Compared to what, and your eyes are not as good as
It's not the distance.
Make
It's
the
the size.
difference.
Yeah.
That is
Yeah, that
it.
size is being different only due to the distance, right?
But comparing a star is more bigger than moon, right?
But
very class.
That is a very valid question.
yeah.
That's a very valid question. And this
Star,
should
star
answer.
is far away from...
No, star is bigger than moon.
But it's
But what you see,
But
Wait, let the speaker answer.
Yes.
Yeah, this is the other question.
Star is bigger than...
Moon.
Yeah, sure. But the distance to the star is much far compared to the moon. And moon is nearby, I would say, but both of them, the light from both has to go through atmospheric these fluctuations. And the blinking is still there, or even in the moon, but moon what we see is bigger in size, diameter, and compared to the star size.
See, I think
And
one point
and the blink-
nobody has